Strings is probably the most important. Well, they're all important, but there are lots of different ways in which you can manipulate strings. So it can be challenging. And besides your textbook, there is more information available from that link. So it gives you some more information about string manipulation. So you may want to take a look at that. So here I have two scalars with string value. So say S1 is just one line, S2 is second line, and S1 comma S2 produces what is contained within S1 and S2. Okay. And if you want, this is just a single line of text or string. If you want to store a multiple line text, okay, as a scalar, then remember we did a multiple line comment before. So same thing. So you have to put them within pairs of single quotation mark or double quotation mark. Either will work. So I have here C equal to, okay, I have two lines of text, and then I print C, and C gets printed in this way. Once again, \n is new line. Okay. Now adding two strings concatenates them. So you have S1 plus S2. So we'll give you we'll add the two. So the thing is, S1 ends with E, S2 starts with an S, and therefore there is no space between E and S. Well, I have to run this first. Okay. All right. Now strings have lots of built-in functions. Okay, couple of them here are len. Len will give you the length of the string value. Okay, so how many characters there are in the string. So len, this is a string, exclamation mark produces 17. Then str returns a string representation of an object. So you can say str something, okay, like str5. 5 is a numeric value. Now str5 will return 5 as a string. So this is no longer, so if you multiply by 3, you see it's going to be not 15, because the 5 is converted into a string, and a string, when you multiply, it just repeats it as many times. Okay. So str will convert anything into a string. Okay. And then we have what is called typecasting for strings. So changing types, change integer to floating point, change numeric values in string scalar into numeric data types. Okay. So we have two types of typecasting. So a numeric value into another numeric value type. Okay. There are two types of numeric values, right? There is integer and then there is floating point. So changing one type of numeric value into another type of numeric value, that's typecasting between two numeric values. You can also do typecasting of string, convert that into a numeric value. Of course, that will work only if what is contained as a string, that string itself is a number. So if a string is not a number, then typecasting that into a number will give you an error because there is no number within the quotation marks. Okay. So typecasting a string into a number okay, is changing numeric values in string scalar. If the string scalar does not have a number, then typecasting won't work. Okay. So for the first typecasting, we have int function. So we have a floating point value, okay, fval is 4.7, right? Now if I say int of that fval, then we're going to typecast the floating point value of 4.7 as an integer value. And when you do that, it's going to drop, okay? It's not going to round. It's not rounding that's happening here, okay? Rounding means this will be 5, right? So this is not rounding. We'll just chop off the fractional part and keep the integer part as is and then convert that into an integer. So that's what ival is, okay? Now the reverse, floating point, okay, you can use float. Okay, sometimes we may need to have floating point values, not integer values, in which case you can use float. Okay? And what that will do is it take the integer value and then put a decimal point and convert it into a floating point value. So that's straight conversion. And there is no problem here in terms of leaving off anything because it is an integer to begin with. It's just converting it into a floating point value. Okay? Okay, now str function converts a number. Okay, so we already saw this. This just takes a number and converts it into a string. Now the question is converting a string to a numeric data type. So typecasting from a string to a numeric value. Okay, and here again use int to convert the string into an integer. So the string must be a whole number. Okay, so that's a requirement. And then use float to convert a string into a floating point number. The string must be a numeric value. All right. So here is a string, okay, and the string, it's not a numeric value, but the string represents the numeric value, and it is a floating point value. So if you say type, what is the type of str? Such a string, okay, and you cannot do any regular arithmetic with this because it is a string, it is not a number. Okay, and if you want to do arithmetic operations with that, then you have to convert it with float. So now I use float of str1 and save it in fval, and then you see this fval. Okay, there is no quotation mark here, so this is a floating point number. Okay. Now if I use int, I cannot convert this into an integer with int because int function requires the string to be a whole number, right? So that's why if I use int, it's going to give us an error because it says what? Invalid literal for int with base 10, okay, which means it has to be a whole number and it is not. So, but if it is a whole number, okay, so let me, this will work, but let's okay, so whole number, then it's fine. and whole number, you can, if the number, a float can be used for both a whole number and a non-whole number. All right. Okay. Another important use for the typecasting is to see whether, remember when we are cleaning data, so we have a numeric column. Now, are there any errors in the numeric column? You try to compute a mean of a numeric column and you get an error. Okay. So what's going on? And you want to check it out, then you can convert the string into floating point. So here str3, it's a string, and you do a float of str3, then it tells you, okay, where the problem is. Okay, here the 0 is coded as an O, the letter O. So there is an error there. Okay. So this is one example of how we can look for errors in the data and then fix those errors. Okay. Okay, and then we have the bool function. Remember, bool function 0 is false, everything else is true. So we have bool of -4, 5.6, a string, and then a bool of true. Of course, that will be true. So these are examples of Boolean values. And then we have bool of none, or this is an empty, this is a empty list. We haven't talked about list yet. Then we have bool of 0, okay, that's also false. Or bool of a null string, that's also false. Okay, bool of false is false.